Hello, everyone, and this is going to be the first lecture looking at the introduction to the study of the brain in regards to memory structures. So, as I go along to these lectures, this is more of an introductory lecture. I do not expect people to write intense note taking on this one. As the second lecture, we'll get into the brain and other important structures. This is primarily a basic introduction without being too intro-like. So I understand a lot of people have taken introductory to psychology, and this lecture is not meant to be an introduction to psychology. It's just a basic understanding of why we study memory. So to begin with, obviously, memory is very important. It's very difficult to define, but there are different ways in which researchers have defined what memory is. Um, Obviously, we know it as a storage system, basically what we can remember and recall consciously. But at the same time, a lot of our memory structures are unconscious, things that we're not necessarily putting a lot of mental effort to remembering something. To give you an example, if you ask me my name, automatic, right? If you ask me my phone number, automatically I'll give it to you without any sort of conscious effort to dig deep and understand what my phone number is. So in memory both makes up the conscious aspects and the unconscious aspects of our mental system. But it's very important, obviously, to study because it deals with everyday life. Passwords are becoming more complex as opposed to, what your first dog name is. Um, where you parked your car, meetings that you have to attend. In today's day and age, a lot of things are digital, and we use our phones to remind us, what's next, what's upcoming. Primarily, since most of us are indoors, right, because of the pandemic. So memory, of course, plays a critical role. And it's one of those things that if you ask a lot of individuals what they fear the most as they get older, and I talked about this plenty of times when I teach psychology of aging, is that one of the things that they fear the most is losing their memory because it's one of the things that we care and hold deeply, of course, recalling our children's activities, recalling our parents, our childhood, and all those things. That's one of the reasons why we study it intensively. So there's a lot of scientific approaches to the way we study memory. We obviously follow the scientific method. We, have theories, hypotheses. We observe things and find a way to study them in a laboratory setting. If you ever taken a class with Dr. Heredia, he does a lot of memory research in his laboratory. But the whole point of research, obviously, is we study things empirically. These are not anecdotal type of research. Like for instance, it always bothers me when people say, well, if you want to improve your memory, um, you know, take so many milligrams of some sort of vitamin or ginseng or X, Y, and Z and GNC and different types of nutrition stores to try to kind of push these things on you. Buy this to improve your memory. But the reality is, it's just not really a known vitamin or drug that can actually improve your memory. But we study it, right? We study in the laboratory. We want to see how people can remember certain things. What are certain strategies that people use to recall events? Can we make people forget? That's true. We could actually make people forget. It's actually a very easy technique that I'll talk about when we get to the topic of forgetting. But keep in mind that when we're talking about research and we're talking about memory, at least in this class, a lot of it is empirically tested, right? We use, in other words, a scientific methods. We do everything in a controlled laboratory setting. So, some brief history. I want to make these lectures, of course, short and to the point. I do not want to make them, for you guys to, have a revisit to intro psychology. But there's a couple of things to remember. For instance, kind of a hallmark in memory research was Herman Ebbinghaus, who studied retention, basically our ability to recall information. Very simple. And one of the techniques he used was recalling nonsense syllables, basically syllables that do not make sense. And there's a whole list that you can find online of what these nonsense syllables are. And the idea is that if you want to study something, at least in a laboratory setting, you want to be able to study them where they don't have some sort of meaningful impact. For example, if I study, you know, my children's names, they have a meaningful impact. So I'm going to remember those things. If I study my dog's names, they have a meaningful impact, at least the ones I like the most. But if I study nonsense syllables, things that don't make sense, then they really don't have any meaning. And it's gonna make me have some sort of effort, like I'm studying new material. So there's something called like the forgetting curve, or I believe it's called the Ebbinghaus curve as well, where there's a specific amount of time where things are remembered very well, and it's basically after you studied them, right? And there's different strategies that people can use, such as you know retention and repeating things over and over again. It's called the repetition effect, and that does improve, right? That does affect your memory. That does make you want to remember things a little bit better, as opposed to not doing them again. But Ebbinghaus is kind of one of those hallmark, cognitive memory researchers that applied a more scientific approach to the study of memory. So there are certain things from Herbert Ebbinghaus that we can put forth in this class. For example, there is such a thing as called overlearning. So if you study the material very well, and I'm a victim of this as well. Sometimes you want to get like the best grade possible, and it's very difficult for us to find that point in which we've recalled the material very well to the point that any additional studying may not be effective. And just like exercising, right? So there's a point in which you can expand your muscle mass that if you exercise more, it's probably not going to be any help. It's going to be more detrimental. Same thing applies with memory. What's called overlearning. Basically, there's only so much you can remember and retain at a given point. That any other time that you spend trying to study is not going to be impactful, and it might actually be detrimental. Where you start questioning your studying, you start questioning what you've actually learned, and that becomes problematic. But at the same time, people can often use different techniques, like the spacing effect, which means that if you space your study, it will improve your study efficiency rather than studying 5 hours in one material. That's actually shown to not be very effective compared to breaking pieces down. But there's some pieces of historical information here that are important to the class. There's also Mary Calkins, which is fundamental in studying paired association learning. When you learn words together, things become easily retained. So it's pairing them, and they don't really have to be meaningful. So like a rainbow and a cathedral may not necessarily make too much sense. Captain and carbon may not make too much sense. But if you pair them within a given amount of time, they might make sense. And they might be recalled a little bit better, specifically if they are strong opposites. Like if you recall bread and pastry together, yeah, it might be easy to recall in a test setting, like pastry may automatically make you remember bread. But in a recall setting or in a situation in which you have to kind of consciously recall this without any sort of hints, like a test exam is a perfect example of a hint. You're giving you key words that may be helpful. Oftentimes, the direct opposite might be effective because it's something that's not very common, and oftentimes things that are unique and not common are recalled very easily. So Mary Calkins, of course, brought forth the paired association learning. The recency effect is something that we basically associate with immediate recall. And it's one of those things that which people tend to remember fresh information a little bit better than old information. And it's, obviously it's common sense, but it's actually a very strong effect in a natural laboratory setting, which I will talk more about when we look at forgetting and those types of important sections. Hey, here are other historical aspects of memory. A lot of these things are intro to psychology stuff that, once again, when you take a specific class like memory, you don't want to delve too much in the intro stuff because you want to get right into the specifics. But if you've never taken an intro class or you're taking this as an elective, kind of fundamental psychology undergraduate information. Behaviorism is a field in psychology that used to be very strong, used to be very dominant, focusing on directly observable behavior, not necessarily focusing on the mental system as this class does focus on. And behaviorism, of course, focuses a lot on things that we can change and alter in an observable context, like classical conditioning, which is a very important type of technique that's used in learning. So associating things together tend to make recall a lot stronger. For example, the classic Pavlov dog study, where you associate a neutral stimulus that's not known in the natural world, such as a bell. You ring a bell, for example. A dog, it might cause a dog to go crazy because it's kind of annoying sound. But that a dog, when the dog sees food, the dog is going to salivate naturally because food is a natural thing, right? And even me, if I'm driving down the highway and I see a billboard of Burger King or whatever, it's going to make me salivate because I like fast food, right? But the idea is that in classical conditioning, if you pair things that are not natural to things that are natural, the response that it produces will make the unnatural stimulus override that natural stimulus. For example, if you pair a bell with food together, the dog may not care too much, but over a period of time, the dog's going to salivate anytime they associate both of them together. And the dog's going to salivate. Like, hey, I think about a bell, it means food, I'm going to naturally salivate. After a while, if you do that over and over again, many, many trials, many, many days, the dogs will start to associate a bell by itself, which has no meaning to food. Now it has meaning to food, and the dog begins to salivate. That's basic classical conditioning, kind of behaviorist principles. And operant conditioning is basically looking at punishment and reinforcement. If I want to teach a dog how to do certain types of tricks, if I give the dog, let's say, for example, a reward, a treat every time they did something, and I do it consistently, that is how dog training is very effective. If I do it consistently, then it starts to make those behaviors a lot more, the dog starts to produce those behaviors a lot more consistent as well. That's operant conditioning. And we do that all the time. Punishment, when we punish our children, I mean, like not physically abusive punishment, but punish our children, right? They start to associate that punishment with the negative behavior and they don't do it again. But when we reinforce them, give them some sort of praise when they pick up their toys or whatever, then that type of behavior starts to become more consistent and they associate the two. And it starts actually producing a favorable response, picking up after yourself. So these are part of memory because we're actually talking about learning as well. And these are very important principles to understand. Endo Toving, of course, also talked about the encoding specificity principle, which is associated with matching, right? The retrieval should match the encoding. And you should think about this when you study. A little bit difficult to do in a current setting, but I would always tell my students in an on-campus setting, next time that you study, try to mimic the class setting. Because the idea is that if you mimic the class setting, you might be able to actually perform better. So for example, like if you give a presentation and you're preparing for a presentation, but you don't see yourself and you don't see your mannerisms and you don't envision the class being there, you just say, well, I'm going to give a presentation, I'm going to time myself 10 minutes, and we'll see how it goes. There's no guarantee that that's going to actually improve your presentation. But if you mimic the class setting, pile up the teddy bears or whatever, and pretend that people are asking you questions, just mimic the setting, it's very likely that that's going to have a positive impact on your presentation. That's what we call the encoding specificity principle, that anytime you try to retrieve the information, so I'm retrieving this information, I'm retrieving my presentation, I will do better if it matches the setting that I prepared myself in. Right? So think about that next time you take an exam or prepare for something as basic as a quiz or as major as a presentation. And of course, there's actually other fields that we'll talk about. Cognitive psychology is a big field. I teach that separately, I believe, in the summer. And it's more of an overarching field. Memory is part of cognitive psychology, which deals with the mental system, how we think, how we process, how we retrieve, how we store information, how those things, of course, fit in the structure of the brain, right? And cognitive psychology uses the computer metaphor as uses the computer as a metaphor to explain its processes. But in the grand scheme of things, there's also cognitive neuroscience, which is more, I would say, probably more computational, looking at the way that neurons and neurotransmitters and the brain's specific architectures are actually impacting your memory. And so it deals with these physical structures of the brain and how they actually impact the way that you cognitively retrieve things, which I'll talk about more cognitive neuroscience in lecture 2. There's different ways that we study memory. We do use experiments, and this is kind of a classic example. If you drink coffee, will that improve your memory? Imagine if you were to do a study like this, what would you do, right? Well, there's different types of methods that we use to teach how people, that we use to, there's different memory structures, memory techniques that we use to measure retrieval, I should say. But, think about this type of study. You give people coffee, right? So kind of, you have your classic experimental setting. You have a group where you give people coffee and you have another group where you don't give people coffee, and they're randomly distributed, right? Nobody has a choice of which group they go to. You measure the performance of a memory test. What kind of memory performance would you use? Memory test performance. Think about that type of study, right? Does it work? I know for sure that if I don't have coffee, I'm very sluggish, I get headaches, get sleepy, lazy. So if you have a caffeine addiction, it probably will work. But let's say, all things being equal, these are these individuals' first time drinking coffee. Does that actually work? What kind of performance dependent measure would you use? Well, there's different kinds. There's recall, where you basically ask people to recall consciously, right? Recall your childhood memory, for example. There's recognition, kind of a matching, right? Multiple choice questions are typical recognition type of questions. There's implicit tests, fill in the blanks, kind of implicit. Right? You think you might know it, but unconsciously you might need some sort of cue to bring that out. Fill in the blank, remove some letters here and there, but give like a cue that people might actually retrieve that information. And there's also things, right? Other different types of memory measures that people can use. There's source judgments. Where was the information learned from? Are you sure you learned this from the doctor's office, or did you actually just learn it from TV, right? Did you actually learn American history in history class, or did you learn it from kind of these conspiracy type of websites that are very common now, or very popular, not very common, they've always existed. And there's also meta memory judgments, right? How did you know that you actually know those things, right? Knowledge of your own memory system is a meta memory judgments, right? But the key point, right, is that there's different ways to actually test memory structures. So, and of course, there's neuropsychology measures, which I'll talk about a little bit more in lecture 2, which are looking at the actual brain structures and how that impacts our memory. There's animal models comparing human memory systems to mice. It's very cool and interesting research. It's actually very effective and very interesting. I work a lot with mice at times, and they do different types of techniques, which are very interesting when it comes down to comparative models. How to improve certain things in mice, how not to improve certain things in mice. Very interesting things. There's classic old videos that show, pigeons performing impressive memory type of techniques. You'll be surprised that you can actually teach a pigeon how to do certain things. Um, and obviously, cognitive neuroscience I'll get to more in lecture two, which looks at actual neural imaging type of techniques and how um, how the brain can actually activate certain structures when it comes to memory retrievals. But that's more in terms of lecture two. So I hope this was a quick, interesting introduction to memory, and I look forward to having you throughout the rest of the semester. And I promise to keep these lectures short and to the point. Um, that way, information can be retained best. Thank you.